Hello everyone. Today we're going to be talking about another conic section called the parabola. Um, by definition, the parabola is a set of all points that are the same distance from a fixed line. Okay, fixed line. That's this line right here that I have in black. And a fixed point, not on the line, this point right here. So it's the set of all points that are the same distance from this line at this point. So if I pick a point right here, let's just do this in blue. This point right here. This point right here is the same distance from this point and this line. So if I were to pick any point along this curve, they would be equal distance from this point and this line. So this line here is called the directrix. The directrix. Okay? And the fixed point is called the focus. So this right here, the point, this is the focus. Okay, that's the directrix and the focus. Okay, so these are the equations of parabolas. This parabola, since it has the y equals out here, it opens up or down. This one opens left or right. Okay, left or right. So if you think about a parabola, the first step is always to figure out the orientation. Which way is it oriented? If it's oriented upward, this number is positive. Okay, this coefficient will be positive. If it's downward, it's negative. If it's facing right, which is the positive x-axis, this number is positive. And if it's facing left, then it's this number, this value is a negative value. So what does P stand for? P is the distance from the focus to the vertex. Okay, the vertex of the parabola is where it achieves a minimum or maximum, right here. So that is the vertex. Okay. So this blue dot is a vertex. So the distance P is this distance right here, from the black dot to the blue dot. That's P. Now, since by definition the parabola, any point on the parabola is equidistant from the focus and equidistant from the directrix, we also know that this distance here is also equal to P. Okay, so P again represents this distance from the focus to the vertex, and P is also the distance from the vertex to the directrix. So now let's look at a few problems. So write an equation for a graph that is the set of all points in the plane that are equidistant from the point F. And line. Okay? So set of all points that are equidistant from this line and this point. By definition, that's a parabola. Now, which way does it open up? Let's look at the graph. X equals -2 is right here. So any point on this line, x equals -2, has an x value of -2. So any point right here is on the line x equals -2. And the point 2, 0, we go over 2, up 0, that represents the focus, right? The focus. So the parabola, we know, is going to be somewhat like this. Okay, it's going to open to the right. Okay, so when we had this equation, h and k where your vertices, the point where your vertex is, h and k, we know it opens to the right, so we have to use the following equation. Now, why did we choose that equation and not the other one? Well, since it opens to the right, we use this equation. And if it opens to the right, we know it's positive. Now, what is the what is the equation of the coordinates of the vertex? How do we know what h and k are? Well, we know the vertex lies right here at the origin, just from looking at the graph. Okay, the vertex is going to lie in between this point right here, 2, 0, and this line, x equals -2. Okay, so we know that 2, 0 is there, and this is -2, 0. So the vertex is the midpoint of those two. The midpoint of that is the origin, 0, 0. So we know this is true. Okay? Now, how are we going to find what P is? Well, P is the distance from the vertex to the focus, or the vertex to the directrix. And P you can see here is just 2. So we have x equals 1 over, it's a positive 1, over 4 times 2 times y squared, which is 1 over 8 times y squared. In the next video, we'll work a different problem out. Thanks.